Good evening, all. Welcome once again to the session, and I must thank my good friend David for sending us the link. I just got the link at the last minute. I was getting a little bit worried. Hi, David. Okay, David is not answering. Okay, guys, we have a small number of people today. No hassle. We are going to continue with whatever we have been doing. So this is the South African Maths Foundation training program. We have 9 such sessions, and today's one is the penultimate one. In other words, the one before the end, session 8. And hopefully you are going to enjoy the session as much as I did in trying to solve these problems. Today's session is largely on probability, if I recall, it's probability. And it is a topic which is in the school syllabus, usually done around grade 12, I think. Um, yeah, and I don't know how people are finding this section, but it's a very interesting section. A lot of it has got to do with counting. All right, and it's very logical. Now, you already know what probability is, I'm sure. In other words, what are the chances of something happening? Um, it usually is represented by a fraction or a percentage or even as a decimal. 100% means it will always happen. 0% means it will never happen. And then you have the things in between. So it's a number which will give you a fairly good estimate as to how good your chances are in doing something. So it's a very important topic. In fact, it comes under another wider term called combinatorics, and it is something that statisticians um, live on probabilities. Okay, so let's just get on with the work at hand. Now, as usual, if there's anything that you want to say, you can put it onto the chat column, and we can answer it towards the end. And if I happen to see it at the right time, then I will answer it. Okay. One of the downsides of these programs is that I don't get to see you or no have any idea how you are responding to what I am saying. So mine is almost entirely a monologue. All right, so let's get on to the first problem. You can see it's number 4. It means that in the problem section, I had one whole book on problems uh, to ponder or whatever. And there I had various sessions, and session 8 must have had maybe 15 questions, but we don't have time to discuss all those. I've just selected a few of them for discussion. And so, in other words, I left out the first 3 problems here. I didn't think that they were totally necessary in this short period of time. And we're going to do problem number 4. Problem number 4 reads as follows: 3 prime numbers, x, y, and z, satisfy the equations. Now, there are 2 equations given here. xy plus xz equals 80, and xy plus yz equals... Nokulunga, can you please switch your mic off? Nokulunga, thank you. So there are 2 equations given, but the thing about these numbers x, y, and z is that they are very special numbers. They are prime numbers. They're not just real numbers or positive integers or natural numbers. It's a smaller set. There are three prime numbers. All right, so let's get ahead and just see what's going on here. You've got the first equation says x. I can take out x as a common factor. X into y plus z equals 80. Now you've got a product of two numbers equal to 80, and x is a prime number. So x now is a factor of 80 because x times another integer is 80. So x is a factor, and it's a prime factor. And the factors of 80, when you factorize it into prime factors, it's 16 times 5. So 16 is 2 to the power of 4. So the only prime factors of 80 are x equals 2 or 5. So there are only two possibilities for x. All right, let's look at the second equation. The second equation, y comes out as a common factor. So y into x plus z equals 425. Now this is 17 times 25. I got a very quick way of dividing by 25. If I take 875, the multiple of 25 will end in 25, 50, 75, or 0. There are only four possible endings for the multiples of 25. And if you want to know how many times 25 goes into this, multiply this thing by 4 and add 1 if it's 25, 2 if it's 50, 3 if it's 75, and of course, 0 in this case, right? So like for instance, this is equal to 25 goes into it because it ends in 75. 8 fours, 32, multiply by 4, and you add 3. 32 plus 3 is 35. So that's how I got 25. 4 fours are 16 plus 1 is 17. All right, 17 is a prime number. And this is, of course, this is 5 squared. So there are only two prime factors here. So y, so y again is a factor of this. Y times something is the, and y is a prime number. So it's y can be 17 or 5. All right, now let's try y equal to 17 and see what happens. If y equals 17, then what do you have? Let's just substitute these numbers inside here. You'll have x into y is 17. So it's 17 plus z equals 80. I am substituting 17 into the first equation. And in the second equation, 17 times x plus z. So x plus z is 425 divided by 17, and we know that's 25. Okay, so now we've got these two equations. All right, now let's try x equal to, we said x equals 2 or 5. See, so in case you tried x equals 5, if x equals 5, then you have that 17 plus z is 80 divided by 5, which is 16. Now that's impossible because this number here is obviously bigger than 17, right? So this is not possible. So this is a contradiction, right? Which means that x, the only two possibilities for x, as we saw earlier on, and so the x must be equal to 2. So this is eliminated. Therefore, x equals 2. Let's just do the writing on this side. So now you have x is equal to 2. Then what happens then? Then you have x plus z is 25. So you got 2 plus z equals 25. And z is equal to 23. Okay, that's fine because 23 is a prime number. Okay. Now let me just see whether the other equation is satisfied. I just used this equation and I got that z is equal to 23. So here in the other equation, check x into y plus z. Z is x equals 2, y is 17, z is 23. 17 plus 23 is 40 times 2 is 80. Ah, that works. Okay, so therefore, the answer that we got here is x, y, z. Always, if you got three unknowns, always put them like this: x, comma, y, comma, z with a bracket. Then we know exactly what your x value is. We saw it's 2, and this is 17, and this is 23. So this gives you your solution to this problem. Okay, so the important thing here was that the prime numbers, if you got a factorization, then into prime factors, then you can see what the prime numbers are, which are the factors in the factorization as prime powers. Okay, so let's just get on to the next problem. Three of the first five positive integers are chosen at random. Okay, I think we can do something with that. The first five positive integers are, are 1, 2, 3, 4, and 5. Those are the first five positive integers. Now, three of them are chosen at random. Oh, but then arranged in increasing order. All right, so you have these numbers are, like for instance, if I choose 1, 3, 4, or 2, 4, 5.
كنا في الروب لسه تلاقيك ما ها يقول لك
Honor,
لا
Honor, can you please switch your mic off? 2, 4, 5. So you take three of these and put them in increasing order. All right. Now they say the probability that the three chosen numbers are consecutive is P over Q, right? In lowest terms, find the value of P plus Q. All right, now to work a thing out like this, you have to find out what is the set of successes, if you like. Um, by successes, we mean the yeah, they are chosen and arranged in increasing order. The three, four chosen numbers are consecutive. So we call them successors. Are, and you want them to be increasing, right? So it'll be 1, 2, 3 consecutive numbers, or 2, 3, 4, or 3, 4, 5. There are only three positive possible sequences of consecutive numbers in this collection 1, 2, 3, 4, 5. Right. So there are three of them. The number is three. The number of successes is three. Right. Now, what are all the possibilities? Actually, we don't really need to know what they are. We need to know more is how many possibilities are there. Not exactly what they are, but we want to know how many there are. Right. So we don't have to list them down. But now we saw, for instance, those two are possibilities. But how many are there altogether? Now the way to do this is actually quite simple. Because the idea is you got the set here 1, 2, 3, 4, 5. I want to know how many ways can I pick three. Once I pick three, then I can just write it in increasing order. So basically, you want to know how many ways can you pick three from five? How many different ways? Now you can do that. You can write down all the possibilities, but it might be easier to say that instead of picking three, I ask myself, how many ways can you lose? Can you leave out two? Because there are five of them. To pick three means you're leaving two out. Like for instance, here I left two and five out in this first example. In this example, I left one and three out. So each time you have a set of two, then you all automatically have the set of three. So instead of counting how many subsets there are having three elements, it's exactly the same as counting the number of subsets having two elements. So I'm just going to put this down as a note. The number of subsets of the set here, you're looking at 1, 2, 3, 4, 5, having three elements is equal to the number having two elements. Because each time you have a set of three elements, you have corresponding to it exactly one set having two elements. In other words, what we left out. See? And conversely, if you take any set of two elements, then you'll say, okay, these are the ones which are left out, and then you'll know what the set of three elements are. Okay, and it's easy to count the number of two elements, and this is equal to, we've done this before, the number of two elements subset is 5 times 4 divided by 2, right? We certainly would have done this thing. Recall, um, the number is n into n minus 1 over 2. That's the formula for the number of two element subsets. That's how I got this, and that is equal to 10. So the total number of possibilities is 10, right? If you want, you can write down all these and you'll see that you got exactly 10 there. Therefore, the probability that the three chosen numbers are consecutive, so that's what we're looking at, is the number of successes over number in the whole set, or number of possibilities. Let's put it that way. Number of possibilities altogether. So these successes will be part of those possibilities. And the answer is 3 over 10. Because we had 3 here and 10 here. Or otherwise 30%. So there's a 30% chance that if you pick 3 consecutive numbers from 1, 2, 3, 4, 5, and there's a 30% chance that they are consecutive, right? So, these things are very useful when you are in gambling. People tell you, all right, we'll give you, put in 100 rands, and if you get the answer right, we'll give you 50 rands or whatever. You might have had a game like this, where they say, okay, look, we've got numbers here, put your hand in, don't look, pick out 3 numbers. If they're consecutive, you know, we'll share 50-50. But otherwise, you lose the money. So here you wouldn't gamble this because you say, look, my chances of winning are only 30%. But in all cases, the chances of winning are always less than 50. Otherwise, the gambling guys would not be making any money. So that's one of the reasons why I follow the motto, a fool and his money are soon parted. Gambling is a foolish pastime. Not only foolish, but it's very dangerous. People commit suicide and they lose everything. Okay, so actually the answer was, we said it's 3 over 10. Now this is in lowest terms, right? If it was 6 over 20, then we'll have to simplify it. But this is in lowest terms, and the value of P plus Q is 13. P is 3 and Q is 10. Okay, so let's get on to the next problem. Okay, we're going to problem 7 now. 3 balls marked 1, 2, and 3 are put into a bag. Okay, so you got to get a bag. And you got ball 1, ball 2, ball 3. They are marked 1, 2, and 3. Okay, a ball is drawn at random. So you can, when you put your hand in, don't look, pull it out. It could be 1 or 2 or 3. So it's drawn at random, and the number is recorded. So I could have drawn the first one to be 2, and then the ball is returned into the bag. So the thing goes back into the bag. So the second round, I can still draw 2. And then again, you return the thing into the bag. So you still have 1, 2, 3 at the bottom. And this time, maybe you draw 3. Like this, you go on. This is done 3 times. Oh, okay. So it stops here. So I could have had 2, 2, 3. Right. With each ball, and each ball is equally likely to be drawn on each occasion. So there's nothing, no prejudices involved here. You know, when you pull out a ball, it could be any one of 1, 2, and 3, and they all have got the same chances pulled out, equally likely. What is the probability that the sum of the numbers on the 3 balls drawn is 6? Okay, so we have to ask ourselves, so what is the probability that the sum is 6? Right, so you've got three numbers now, 1, 2, 3, and it's done three times, so you may have three numbers. Uh, so what numbers could you possibly have to get six? Could be 1, 2, or 3. So I could have picked up 2 in the first instance, 1 in the second, and 3 in that. Or I could have picked up 3, 1, and 2, or 2, 3, and 1. There are many ways of doing it. But at the end of the exercise, I want to know whether the numbers that I picked are 1, 2, and 3. Right? That gives you 6. Or you can also, I could have picked up 2, 2, and 2, because these the numbers go back into the bag. So I could have picked up 2, 3 times. Like, yeah, I picked it twice. Okay, so these are the successes, right? Now in this case, yeah, I could have had one first, second, third. So if I list all the possibilities, yeah, the first number being the first draw, then these are the possibilities, right? So how many are there? Yeah, there's 6, and here there's 1. There's only one way where you have 2, 2, 2. So the number of successes is equal to 7. So there are 6 of them. Yeah. So there are only 7 ways in which you can get the sum 6. Now, how many do you have altogether? Okay, I've done something like this when we did counting. Okay, so the first draw, this is draw 1. Let's call it draw 1, draw 2, draw 3. The first draw, I could have had any one of 1, 2, and 3. Right? So there are 3 possibilities. It could be any one of 1, 2, or 3. Right? And then the second one, the thing is put back inside. So you still have the number the 3 balls there. So there too again there's 3. And again, you put it back inside, you got that. So the number is equal to 27. There's 3 times 3 times 3. Now, in case you didn't understand that, you can you can look at this to see how you're going to count all these. Mm. Okay, so I could have drawn, for instance, I could have drawn 1, 1, 1. I could have drawn 1, 1, 2, 1, 1, 3. Okay, so the first 2 could have been 1, 1. Or the first 2 could have been 1, 2. Or the first 2 could have been 1, 3. Right? So here you are, in each case you can put these are the possible draws. Now, with the first one being 1, there's already 9. You see? Now, if I change the first one to 2, again, I have another 9. If I change the first one to 3, I have another 9. So that is how you get 27. See? You can list all of them down, but it's just a waste of time. So the way to do this is what we call the counting principles. So how many ways can you fill the first one, second one, third one, multiply the whole lot, and you say it's 3 times 3 times 3, which is 27. So the probability is equal to the number of successes, which we count to be 7, over the total number, 7 over 27. So that is the answer. So you need to count, and we've already done counting, so this shouldn't be too difficult. So this is a good example of counting using the second counting principle. Okay, so let's get on to the next problem. Okay, let me just chat to you. Okay, oh, well, we have 12 people in now. We had 6 at the starting point. Okay, guys, I hope you managed to catch on some of the things. We've done 3 or 4 problems already. Three, I think. It's all about probability. Are there any comments, any questions you want to ask? You can put it on chat now. And all right, so it seems that all of you are quite happy so far with the problem that we have done. Probability basically is the number of successes over the total number of possibilities. Right. The successes means there's some things says, what are the chances of a head falling, or what are the chances of it's going to rain today? Some event or some number, and you have to see what the ratio of that is, the whole thing, and that will tell you what probability is. All right. So since there are no questions, I'm just going to continue uh, with this. So now we go on to, again, more probability. Teams A and B are playing a series of games against each other. The probabilities of either team to win any game are equal. Or in other words, Team A and Team B are equally strong. If it wasn't strong, then we will always have the chances of winning for one team will be more than the other, but it's not like that. They've got equal chances. Either Team A must win 2 games or Team B must win 3 games to win the series. So they got a number of games to play, and Team A must win 2 games, and Team B must win 3 games to win the series. Right. Now put another sentence here. They stop playing as soon as one of them is declared the winner. I mean, if Team A has to win 2 games to win the series. Now, my contention is that if Team A wins play 2 games and won both, there's no reason to continue the play. Why should you torture B? So you just declare Team A to be the winner. Now, in the original question, they didn't say this. They didn't say they stop playing as soon as one of them is declared a winner. And so the answer that they got is very different from mine, because they assumed that the teams are going to continue to play, and they even assumed in the answer memo that they played 4 games altogether. I see that as being highly improbable. Why would the only 2 teams, unless they are part of a league where they have to play all the games? But here it just says A and B are the only 2 teams in the story. So it doesn't make sense to think that they are playing any more games than the number of games that is necessary. Okay, with that now, let's just see what are the possibilities. Okay, I'm going to put down, for instance, if I put down A like that, it means the first game, A won. So I'm only going to put down the winners. So A could have won the first game, and A could have won the second game, and now A has won two games. So the game stops. That's one of them. All right. I could have had A won the first game. Now, watch carefully. I could have won A won the first game and B winning the second. That's the only other possibility for A winning the first game. Now they'll continue playing. All right. Now, suppose A wins, then they stop there because A has won two games. But otherwise, B, suppose B won twice. Now A is won once, B won twice. This this is finished. We can count this as a as a success because A won two games. Probability of A winning the series. Right? I could have had A B B, or could have had A here the fourth game. There's no decision at this point. We have had this, or I could have had A B B B. I'm talking about this. Look, A B A that finishes. Now the other alternative is A B B, but now A B B there's no declaration. There's no uh, declaration of a winner there. So you could have had continue to play and A wins. In that case, you got A wins twice, so that's a winner. And here, A is not a winner, so B wins. B must win three games to win the series. All right, now these are all the possibilities where A wins the first game. But suppose B wins the first game. Okay, then you could have had BA, no decision, or I could have had BAA. Or I could have had BAB. Right. Here too, there's no decision. So they continue to play. And they could have done this, or BAB, B. Either A wins the fourth game or B wins the fourth game. In this case here, A wins the series because you've got two A's. This one here, B wins the series in this case. But you've got three B's. So we can't count this. All right, so you could have had B winning the series. Now, yeah, I've taken all the cases where BA, BA. I still have to take the case of BB. If A wins the series, no decision. I'll just put the other one here. If B wins the series, then this is counted as a failure because A, you have to find out how many times does A win. So you got that. Now, if B, A, no conclusion here, but you could have continued with that, in which case B with the series, or you could have had BBA. I have BAB, A and B. BBA, A and B. Should have put A here first. But anyway. And here A wins the series. Or you could have had that one. And I think those are the only possibilities. The B wins the first game, And if A wins the second game, then that rules it out. So the BA is finished there. But if B wins the third game, you can count it like this. So how many successes are there? Three, six. I think these are the only ones. Six. And you got one, two, three, four, five, six, seven, eight, nine. So the probability that A wins in six of those nine cases, the nine or 10. One, two, three, four, five, six, seven, eight, nine. Oh, there's one here as well. The probability that A wins is 6 out of 10. So he's got a better chance of winning. But in the simplest form, we can't put 6 out of 10. It's 3 out of 5. The twos cancel. So the probability of Team A winning the series is expressed in the simplest form as 3 over 5. So that's x. X is 3, y is 5. So x plus y in the simplest form is 8. X is 3 and y is 5. And that is the answer to the question. Calculate the value of x plus y. Okay, so we go on. Okay, the next problem. Just excuse me for a moment, please. Thank you for your patience. The problem was that I was going off to sleep while I was talking. This was to put some cold water on my face. All right, now you have the next problem. A jury of 12 people has to decide whether or not a person is guilty. An absolute majority, that means 7 or more, is needed. It is known that 4 will say yes. Oh, all right. So you already know the decision of the 4, and you also know 3 of them will say no. So that makes 7 people. You know what they are going to do. The only thing is that there are 5 people left now out of 12. You don't know what they are going to do. Okay. So the question mark is around the 12 as to how they will decide, whether they will decide that the person is guilty or not. So each one will say yes or no. Okay, and there are 5 people who you have to worry about. Okay. Now, of the rest, 4 of the rest four, I see. So they were each toss a coin. So they're not sure whether this guy is guilty or not. So they toss a coin, deciding on the person's whether he's going to live or not was a toss of a coin. Oh. Anyway, so they will toss a coin, and if heads, it is yes, and tails, it is no. Okay, so the remaining one, now you got 7 plus 4 is 11. There's only one last person. He will vote with the majority. Now remember, 11 people would have voted, and there would be a majority. You know, you can't have them the same number of yeses and nos because there are 11 people. Could be 6 and 5, 7 and 4, something. Because he will vote with the majority. What is the probability that the person is found guilty? Well, it looks quite a difficult problem. Let's analyze this thing to see exactly what we are counting. Okay, it's all about those 5 people and what they are doing. So you have these 5 people, but actually not 5 people. The fourth one stays out. We'll just the fifth one stays out, and he will decide. He'll vote with the majority. Okay, so let's look at what the 4 people are doing. So you can have these 4 people. They are doing things like this: guilty, 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 guilty. Actually, it's heads or tails, but this is all heads. Excuse me. So you're gonna have things like this now. You could have had yes, no, or no, no, yes, no. You know, so you can have all kinds of things here. So there are various ways in which those 4 people, the 4 members of the jury, can vote. And so how many ways can they vote altogether? How many possibilities are there altogether here? Well, if it's random, you will have you got four blocks, and each of those blocks, 4 spaces, you can put either a yes or a no. So I could have had 2. The first one be either yes or a no, yes or a no, yes or a no, yes or a no. So there are 2 possibilities for each of those blocks. So therefore, total number of possibilities is 16. So there are 16 possible ways in which these people can vote. Right. Now, let's see. So is a person guilty or not? What is the probability that the person is found guilty? Now, remember, of the other 3, uh, 4 of them, I've already said yes. And for the person to be guilty, for the guilty verdict, four people have already said yes. You want the majority of the 12 people to say yes. You'll need 7 or more out of 12. Right. You already got 4 in. And so you'll need 3 more. So you need 3 of these people to say that the person is guilty. But actually, not quite. Because if two or more, then we have already we have 4 plus, you'll have 6 out of 12. No, I'm sorry, 6 out of 11. The 11 people have voted, right? So that's the majority, right? And the last guy will say yes. Because as long as of this 4, each will toss a coin, the remaining one will vote with the majority, right? So if it's 6 out of 11, that means the majority are saying yes, and he'll also say yes. But if the majority was, if it was 5 out of 11, then he's going to say no. Because then there would have been 6 people who are saying no. And so this one is, he just vacillates. He goes along with the crowd, as it were. Okay, so in other words, we need 2 or 3 or 4 yeses. In any one of these cases here, the person will be found guilty. Okay. So you have to count how many ways. Yeah. All right. So you can count how many ways, how many cases there are like this. That's 2 or more. So this is a winner. This thing is not a winner because now you'll have more yes, more no's than yeses. And here, this is a winner. Okay. So the question is now, 2 or more, instead of counting 2 or more, we'll rather count out of the 16, how many of them are 0 or 1? So how many are there having 0 yeses or 1 yes? Now the 0 yeses, there's only 1. In other words, all are saying no, right? This is the 0 yeses. And with 1 yes, you can have the first yes. First one is saying a yes. Second one is saying a yes. Third one is saying yes. Or the fourth one is saying a yes. All right, so the total number is number of failures. We'll call this failures. Is 5. In all these cases, the person will be found not guilty, right? Then the ends predominate. So how many cases will they be found guilty? So the answer is, so in 5 of them, it looked like this. The remaining ones is 11. So in 11 cases, it's 2 or more. So instead of counting, there's quite a lot to count. You have to write down the whole 16 and then check to see how many of them have got 2 yeses, 3 yeses, or 4 yeses, and then you add them all together, and you will get 11. You'll actually get 11, right? Because altogether you got 16, and we are eliminating those which are not counted in this process. So whatever is left behind will be the successors. So this is 11 out of 16, and therefore the probability is 11 out of 16. 11 cases, the person will be found guilty, and there are 16 possibilities altogether. So therefore the probability is 11 in 16. That's the answer. You see, you don't need too much of mathematics or anything like this. It's just you have to figure out how to count, and that's it's very important in the process of counting that there's no duplication. You don't count anything twice. That is usually the challenge. But if you do it systematically, like the way I do, you will see you can get a proper count. All right, so we go on to the next problem. No assignment this week. Happy, happy, happy. Sometimes they put hearts here. Okay, no assignment. You have been let off, guys. I'm not sure why I did this, but you have been let off. Have a break. So let's get on to the next problem then. Okay, here you say the number 16 is placed in the top left corner square of a 4 by 4 table. Okay, so you got this 4 by 4 table here. The top left corner, so 16 is placed in here. Okay, the remaining 15 squares are to be filled using each of the numbers 1 to 15 once only. Oh, so you got the 15 numbers here, and you scatter them around 1, 2, 3, 4, 5, and so on until you fill all the 15 numbers. But don't repeat any of those numbers because there are only 15 squares. So, and you got 15 numbers. So you can't have any one number more than once. All right, so we don't know how these numbers are placed here. Okay, but the sum of the four numbers in each row, each column, and each main diagonal is the same. Okay, now this is your magic square. You got the same sum. So suppose you call it S. When you're summing all these, you get S. You can sum a column or you can sum a row. And you're going to get the same answer. And you can even the diagonals to each main diagonal this way. There's your main diagonal. And the secondary diagonal is this one. That's also S. Here you got this. Now, what is the sum of the six numbers in the shaded square shown below? None of the numbers are given. We don't know how these 15 numbers are. We're dancing around in these empty squares. But you want to know what the six numbers are in the shaded square. It looks as if it's impossible. But you want to know the sum of the six numbers. So let T be the sum. Anything, you can call it anything, but we'll say the sum of the numbers in the shaded squares. All right, so these numbers here add up to S. Those six numbers add up to S. Six numbers in the sum. Okay, now can we actually calculate what the sum of each row in the columns are? What is this? Well, let's see. You have if you add these all the four rows, 4s equals sum of four rows, or you could have had even the four columns. Doesn't really matter. That's equal to 4s. But when you add up all the numbers, you're adding all the numbers from 1 to 16 because they said that all the 16 numbers are placed in these 16 squares. Right, so this is what you're adding. Wherever they are, you're adding 16 numbers, and this is what it will be. Now, here you know the formula for this. This is 16 times 17 over 2. So that's 4s. That is 8 times 17. 2 goes into 16 8 times. That's 4s. So therefore, s is equal to 2 times 17 equals 34. So the sum of all these numbers are 34. And even the columns are going to be 34. And the diagonals, the two diagonals, can be 34 in every one of them. All right. So just remember, 34 is the constant sum. We could call it the constant sum. Right. Now I got 16 here. So I know that the constant sum is 34. So these these three numbers will add up to 18 because the row sum will be 34. You got 16 here. In the same way, this column sum here is also 18 because the whole thing add up to 34. And even these three white ones, they add up to 18. So let's just put these numbers here like this and put these numbers here like that. So now you've accounted for all the numbers together with S. The six numbers add up to S. So let S be the sum of the six in the shaded squares. Okay, so now if you add up everything, S plus, that's the dark squares, plus all these others. Now let's add them up. What do you have? You have got 16 plus 18, 16 plus 18, plus another 18, plus another 18. Three 18s you got. 18, 18, 18, and 16. That gives you the sum of the numbers in the white squares. Right. This is equal to sum of white squares by abuse of language. It's actually we're supposed to say sum of the numbers in the white square. And this one here is dark. S is the sum of the dark squares. Now this gives you the entire thing. We have counted all the white squares together with all the dark squares, and we've already worked out that this is 16 times 17 over 2. The sum of all the numbers. 1 plus 2 plus 3 all the way up to 16. And it's n into n plus 1 over 2. So now that gives you a good idea of what S is. So S is equal to this thing here. 16 times 17 over 2. I'll make it 8 times 17. There are no calculators. So you have to try to use ingenious methods of making these calculations. Here you got uh, S plus this equals that. So therefore S is equal to that 8 times 17 minus these four numbers. Uh, and these four numbers, you can see exactly what they are. 318 is 54. 54 plus 16 is 70. So there it is. You got 8 times 17. So 136 minus 70. And that gives you 66. So the sum of the dark squares together with the sum of the light squares gives you 136. We know what the light square sum is, right? It's 70. Well, the sum, light square sum, yeah, is equal to 70. Okay, so that's the answer. The sum of they want to know what is the sum of the six numbers in the shaded squares. Okay, let's just get on to the next question. Boy, am I feeling sleepy. Mm. Okay, points A and B with respective coordinates 3A and 11B lie on the same line, y equals root 35 times x plus k. Oh, so at last we've got a problem in graphs. So there it says you're drawing a graph. Right, all these points, they lie on the same line. So this is of the form y equals mx plus c. You'll notice. So this is a straight line. So the graph is a straight line. So he's asking, these points, they lie on the same line. So let's just draw this. The slope is root 35, so that is positive. We don't know anything about k. Right, so this is the equation of the line. Right, so with respective coordinates 3a and 11b, so when x is 3, y is a. When x is 11, y is b. This is a. So these are the points a and b. So the problem is to find out the length of AB. What is the distance between A and B? So I presume that most of you are familiar with the formula for the distance formula. So you got the coordinates here. So the distance between A and B will be 11 minus 3 all squared, and you'll have B minus A all squared. That's the distance between A and B. So we have to calculate this quantity. But remember, these points actually lie on the line. So the x coordinate and the y coordinate satisfy this equation. So in other words, when x equals 3, y equals a, it satisfies that point lies on this line. So the point 3a must satisfy this thing. So you got a, that's your y, equals root 35 times x. Root 35 times x, now the x value is a, plus k. Right, so taking into account that this point lies on the line, you can substitute the x and the y. Very, very important thing, very important fact. Whenever a point lies on a graph, you can substitute the two coordinates into its equation. There's a connection between the graph, the coordinates, and the equation. See? Whatever the equation usually is a nasty piece of work, but in this case, it's a straight line. So this y equals mx plus c. All right, and then likewise, oh, by the way, this x should have been when x is 3, y is a. So I'm supposed to have that, and b is a similar thing. It also lies on the same line, so I can put 11 here. So it must satisfy the equation. X is 11, y equals b, and we wanted b minus a. Subtract the k's go away, so you'll have root 35. That's a common factor into 11 minus 3. I'm subtracting this minus this, but I'm sort of looking at backwards, upwards. This 3 times root 35, 11 times root 35 minus 3 times root 35 is equal to 8 times root 35. K minus k is 0. So that's b minus a. How's that? We got b minus a. So that immediately allows us to substitute the b minus a all squared is 64 times 35. I'm not multiplying it out. I usually just leave things in that difficult form. In the end, things may cancel off, in which case I don't have to do all this work. I don't have to multiply 64 and 35. And all probably I'll get it wrong. So you've got this distance here. 8 squared plus 64 times 35. See, on the left-hand side, I got distance between A and B. So I'm calculating all these. So what do you have? This is um, 8 squared plus 64 times 35. So I can take out 64. So square root of 64. This is 64 into 1 plus 35. 64 at least. And 1 plus 35 is 36. You got square root of 64 times square root of 36. And that's, you see, you don't have to simplify 8 times 8 and add up all these things. Just do the calculations at the end. The calculations at the end. So this is 6 times 8. It's 48. So that is what was required in this problem. All right, so you got, I'm sorry about the long pause. Um, so the answer to this problem here is 48. Okay, let's get on to the next problem. Let me just pause here for a moment and ask you whether you got any questions. Any comments, any questions so far? Okay, so you got a problem on analytical geometry, and there's a formula for the distance between 2 points, and I use that formula. Uh, in case you didn't understand that formula, you can do it like this if you like. Uh, I killed my screen. There we are. Okay, so I'm sharing the screen here. Yeah, the distance between 2 points, I could have actually explained why. You got 2 points. One is 3, and the other is 3A, and here you got 11B. And the question is, what is the distance between these points? What is the length of this line segment? The trick to work out the line end of the line segment is to complete the right angle triangle. And then I draw a line vertical like this, like that. And then I ask myself, what are the coordinates of this point here? Well, the x coordinate will still be the x coordinate of 11, right? The y coordinate of this distance here is the same as a. See, the y coordinate is the same as the y coordinate of that. So now you got these 2 points at the same level. X coordinate is 3, and this is 11. So the length, so if you take how far is 3 from 11, that's really the question. And the answer is 11 minus 3. And likewise here, you got this point here is A, and this point is B, and you want to know what is the length of this line. It's actually equal to B minus A. And from Pythagoras, this distance here is square root of this squared plus that squared. That is how we've got that formula. You see that the distance between those 2 points is 11 minus 3 all squared plus B minus A all squared. You subtract the x coordinates, square it, subtract the y coordinates, square it, and they take the square root of that, and that will be the distance, because that's Pythagoras tells you that the hypotenuse is the square root of the sum of the two sides. So that is where that is coming from. Okay, I should have explained that, but I went off to sleep. I've got this problem keeping awake. All right, so you've got this problem here now. Compute it's the last problem. This looks a little bit nasty here. Compute the following product in its lowest terms. Okay, you got a product of several quantities. Let's give names to these. This is too nasty. Let's call this uh, term one. This is term one. Let's call this term two. And this is term, okay, the one is f of one, f of two, and this is 2024. Now, in case you didn't know about functions, this is functions can be given. This is an expression involving n squared plus 3n plus 2. It means I can put any number here. I can put 10 here. I'll get 10 squared plus 3 times 10 plus 2 and calculate that. You can put any number and you get an output. Your input is your 10 and your output is whatever the answer is, right? And you can give a nice expression for this. You can put f of n, and that means now you can put the inputs go here inside here, the n, and the outputs are here. Right. So f of 10, for instance, is 10 squared plus 3 times 10 plus 2, and you can calculate that. Okay. So that is what these f's mean. The f is the name given to this particular rule. The rule being, if you take a number, you square it, multiply it by 3, and add those two, and then add 2 to it. And you get an input and an output. Okay, so the question is, what is this product here? It looks rather nasty. So we need to know what is the product. P2024. I'm going to call it 2024. So that's the last, it finishes off here. I could have gone on. Next one will be 2025 and so on. But it just truncates at 2024. So now in general, what is Tn? T1 is that, T2 is that. So Tn is 1 minus 2 over f of n. T1 is 1 minus 2 over f of 1, and so on, f of 2 here. The 2 remains the same at the top there. Right? The 1 is also carries over right through. The only thing that changes are the numbers inside the so-called function. Right? And the values of n start from 1 and finishes off at 2024. So there are lots of terms in this product. Okay, let's just, we know what f of n is, so we can simplify this. This is equal to 1 minus 2 over n squared plus 3n plus 2. The f of n, this is the formula given to this. And now this is just an algebraic expression. The common denominator is n squared plus 3n plus 2. And the numerator is n squared plus 3n plus 2. Right? So you're subtracting two fractions. One goes into this, multiply, minus, this goes into this one time, minus 2. So you have 3n squared plus 3n plus 2 minus 2. So this is n squared plus 3n. The 2 minus 2 cancels off. And here you have n squared plus 3n plus 2. Oh, so you have an expression which is the bottom part is 2 more than the top part. Okay, so that's what these things simplify to. Let's not worry about that for the moment. Let's factorize these. N is a common factor here. N into n plus 3. And here, this factorizes. It's n plus 1 into n plus 2. It's a trinomial. It factorizes. So these things can be calculated. All these t's can be calculated very easy. This is the nth term. And let's just summarize this. The nth term is n into n plus 3, n plus 1 times n plus 2. So it's easy to write down the nth term. You put n, underneath that you put one more, next one, add one, and come back to that. So the 4 consecutive ones here, see? N, n plus 1, n plus 2, n plus 3. So I can work out each one of these if I know what n is. Now let's look at this. Here, n is 1. So the first one is 1. As we said, we put 2 here, we put 3 here, and 4. N plus 1, n plus 2, n plus 3. So it's 1, 2, 3, 4. That is T1. Now what is T2? This time n is equal to 2. So you'll start at the top there. 2, 3. Remember, we are multiplying here. 2, 3, 4. Come back there. 5. And so on. Let's do one more. 3, 4, 5, 6. And you're going all the way up to, I'm going to go all the way up to Tn. Let's put on Pn here, right? The product of n terms. So these are all multiplied, they're not added. They're all in brackets here. And this last one, I'm going to put n here, n into n plus 3, n plus 1, n plus 2, n plus 1, n plus 2, n plus 3. Now you got, let's just put all those numerators together. Let's make this a little bit neater. Let's draw a long line here. Right, I'm going to take the numerator. Everything is being multiplied now, right? Everything is being multiplied. So we can multiply everything in sight at the top and the same thing at the bottom. But I'm going to just take the first one. See, 1, 2, 3, all the way up to n. And then the second one, all multiplied. This time I start with 4. 4 times 5 times 6, all the way up to n plus 3. Second term, second term, second term, goes up to n plus 3. Now at the bottom, I have something similar. If I take the first ones, I'll have 2 times 3 times 4. What's the last one? It's n plus 1. And the second factors, 3 times 4 times 5. I'm trying to look for some pattern. This is n plus 2. Try to get some order into this thing because this whole thing is mumbo jumbo here. We can't make head nor tail of what's written there. But if I notice that the first ones keep increasing by 1, then I can actually rewrite this thing in some decent form, like the way I've got here now. Okay, I don't need this anymore. I've used this thing quite nicely. And let me see what we got here. Evidently, I have to cancel quite a lot of things. Okay, if you look at this now, 1 times 2 times 3 all the way up to n, 2 times 3 times 4. There's no 1 here, but we can put a 1. Why not? 1 times anything doesn't change. So I could have had a 1 here in front. Let me just put that in red. But that wasn't there in the beginning. 1 times, right. Now you see, the 1's cancel, 2's cancel, 3's cancel. And there is an n just before this. The thing also cancels. The one just before this would have been n because these are increasing. So the n cancels, all these cancel, 3 cancels. So the only survivors here is n plus 1 at the bottom, as far as these two are concerned. Now here, it's a little bit trickier. I've got a 3 at the bottom, which wasn't there. It's not at the top, but the 4 certainly cancel. And yeah, it finishes with n plus 2, And here I got n plus 3. So the n plus 2 would have cancelled with the one just before that. There was an n plus 2 here just before n plus 3. That would have cancelled. So what are the survivors? The survivor is n plus 3 at the top. That's the only one which survives, n plus 3. At the bottom, I got n plus 1. And the 3 also sort of quietly in here. I had to put the 3 in because only the 4s cancel. The 3 still is very much alive and kicking. So that's your nth, the product of n terms, you got a very nice formula for this. Let's write this thing uh, this way. So you got Pn equals n plus 3 into 3 into n plus 1. And we are interested in P 2024. So this gives you a formula for any n. I could have finished off with any number I prefer to, but this particular one is 2024. So you got 2024 plus 3, that's n, 3 into 2025. Because you got n plus 1, right? So you got 2027 at the top. Yeah, 2027. And 3 goes into 2027 1009 times. This 3, this thing here is 2027. So 3, oh, wait a minute. No, no, no. 3 doesn't go into this one. Okay. Sorry about that. I thought 3 goes into that 1009 times. It doesn't. So the actual answer is 2027 over 6075. That is, compute the following product in slowest terms. And well, I presume that is the lowest term, but you can see the prime factors here are 5, right? And as I told you, this is this is 75 here, so it's 25 times 60 times 4 is 240, 243. 60 times 240 plus 3 is 243. I have to add 3 because I got 75. And this is 3 to the power of 5. This is 5 squared. So 3 doesn't go into this, 5 doesn't go into that. So therefore, this is the lowest term. You can actually prove that you can't simplify this any further. Can't consider any common terms. Okay, so this was quite a teaser here. And that brings to an end, guys, the, yeah. Before you go, I just want to speak to you a little bit. Okay, um, so we have 7 people here. I want to see how many of you actually got. Did you get the results that you got into round 2 or round 3? I don't know whether you are aware of it. I'm not sure even whether the awards festival is over or what. Did any of you get into the top 10 or top 100 or whatever? Nobody? Oh, okay. Okay, thank you very much. Bye. I think some of you got into round 3. I'm not sure. I didn't get the results. But if you got into round 3 or the top 10, that'll be good because the whole purpose here is to try to encourage people, try to help people to get into round 3. Okay. How many of you actually wrote the third round paper? Show of hands. Press react like that. I can't see anything. Oh, D. Kumarasamy, right? Okay. You got into round three. All right. Okay. Thank you very much. Okay, I'll see you next week. Where are we? Today is Monday. Yeah. The next week will be the last session, and I don't mind going on. If some of you are interested, I'll give you lots of talks on interesting mathematics. I'll continue with some some lectures, uh, and if you're interested, we'll try to contact you. Okay, thank you very much for attending. Also, we got the names of all those people who left. All right. Okay, you take care now.